right, it looks like a good amount of people are rolling into the webinar. So let's go ahead and get today's session started. As I mentioned, our webinar today is titled Energy Management and Manufacturing 101. EnergyCAP is sponsoring this webinar in partnership with EpiSensor, and we will get right on into it today. My name is Amber Artrip. I'm the Vice President of Marketing here at EnergyCAP, and I'm joined today by Brendan Carroll, who is the CEO at EpiSensor, and Alberto Guerrero, project engineer here at EnergyCAP. So a little bit of what you can expect from today's session. We'll spend some time going over introductions. We're going to dig into the stages of an energy management project. We'll also unpack some energy design considerations, stakeholder considerations. We'll share a story from a customer case study, and then we will, of course, open it up for questions throughout the presentation. If you have any questions, please use the Q&A tab in the Zoom webinar toolbar right there. We'll be fielding these questions throughout the presentation, and we'll get to as many as we can at the end. And just a few other housekeeping items. We will also be recording this webinar, and it will be available within 24 hours post event, and we'll be emailing that recording to everyone who's registered. So first, we want to kick this off with a poll just to get to know you a little bit more. And we want to understand kind of what are your top priorities when it comes to energy management. So take some time. We've got here data-driven operations, utility management, tenant billing, cost savings and reduction, sustainability, regulatory compliance, and other. Feel free to select all that apply. We kind of want to understand which of these are the top drivers. So we'll give you all a few minutes to submit your poll responses. Okay, sustainability is leading the charge right now, followed by data-driven operations. There's still some submissions coming in, so I don't want to speak too soon, but yes, I'm going to go ahead and end the poll so you guys can see the results. 58% sustainability, 42% data-driven operations, followed by cost savings and utility management. Really interesting. You can check out those results right there. Okay, well, that gives us some good understanding of where you're coming from and helps us understand kind of how we can best support you throughout this conversation and kind of tweak our presentation a bit to accommodate. Thank you. So first, I want to introduce EnergyCAP for those of you who may not be familiar with our product, our software. We're a software company, software as a service. We've been in this business for 40 plus years. People know us best for utility bill management, but we are so much more than that. We are an energy and sustainability ERP, and we are the single source of truth for all energy and sustainability data for our customers. We have three core products: EnergyCAP Utility Management, which is our utility bill management platform for that portfolio level energy and sustainability reporting. We also have EnergyCAP Carbon Hub, which is our carbon accounting software solution for that financial grade scope 1, 2, and 3 carbon accounting. And then finally, the product we're going to be spending the most time on today is EnergyCAP Smart Analytics for our clients who want to dig deep into their facilities and their operations and understand what's happening in real time. This is our real-time energy and sustainability analytics solution, which we're going to be getting into a little bit more today. So what is EnergyCAP Smart Analytics? I mentioned, it's that ability to have that real-time energy and sustainability analytics. We're able to capture data from various sources, interval data, near real-time data, monitor that data on your behalf, and detect any outliers, anything that's, off in your buildings. We're able to understand what those outliers are and provide alerts and alarms to energy and facilities operators to go in and fix those issues in real time. And then also in this solution, we have a variety of analytics tools that allow you to have robust reporting, dashboarding capabilities for sharing that information. And it's important to note too that with EnergyCAP Smart Analytics, we have a variety of integration opportunities. We're data agnostic, hardware agnostic. We can pull in information from anywhere. We do have a number of connected devices and systems that we already have baked in integrations. So EpiSensor, our partners that are with us today, are one of those wonderful integration partners, and you're going to be learning a little bit more about them. And with that, I'm going to pass it over to Brendan from EpiSensor.
Thanks very much, Amber, and it's very nice to be on the webinar with you today, and thanks to EnergyCAP for inviting me along. So I'll just cover what I'm going to cover first. So I'll give you a quick introduction to myself and to EpiSensor and where we fit in. We have, I think, about 15 minutes or 20 minutes, not a huge amount of time, but hopefully we'll be able to sow a few seeds, and I'll try and leave you with a few things based on my experience, 15 or closer to 20 years working in this space now. And leave you with a few rules of thumb based on my experience, as I said, some questions to ask of your suppliers, because the list of hardware integrations that Amber had on the last screen is quite comprehensive, and there's a lot of options out there in the market. So I'll leave you with some questions for your suppliers and the solutions that you might be looking at that should apply in a pretty generic way. We think EpiSensor is great, obviously, and EnergyCAP is great, but we've tried to make this content as general purpose, so it's useful in the kind of your evaluations of these kind of systems. Yeah, so with that, and then we'll do an overview of the life cycle of an energy management project, and then look at a case study in a particular manufacturing environment. So a little bit about EpiSensor. EpiSensor has been around since 2007. We provide the IoT infrastructure behind some large-scale, distributed, secure, mission-critical energy services. So you can think of us as a toolbox to gather data and to communicate with things in the real world. And we deliver data into software platforms that add value, visualize it, report on it, and make use of it in some way. So we're focused on the lower level kind of layers in the system architecture. In terms of the landscape, there's a diagram on the bottom left of this screen here, and this is kind of how we see the market breaking down. You've got traditional control and automation systems on one end, generally produce high quality data, but we think they're too difficult to work with and too slow to deploy. Again, on the consumer IoT device side, generally easy to work with, but suffer in terms of data quality a lot of the time. And the kind of energy efficiency or sustainability outcomes have to, those outcomes are built on the foundation of the data that goes into the platform. And if you've got bad data in, you've got poor outcomes out the other side, generally speaking. So EpiSensor tries to take the best bits from both of those worlds, high quality data, easy to install, resulting in lower cost and faster moving projects for our partners. So we focus on three applications or three application areas. They fall into energy management is the main focus here. Demand response, which is a really exciting area that we're deeply involved in. We might touch on that a little bit later, just because it's important and interesting. And then other energy-related IoT applications, and I'll talk about that a little bit more in the context of the Kelly. So in terms of our product range, we have 5 product families. I won't go into too much detail on this. There's a bunch of information available on our website, but you can think of these 5 product families as covering pretty much anything that you would be interested in terms of energy management projects. So they enable you to collect data from any kind of existing metering or utility or parameter that you would need to monitor. So I'll talk in general rather than specifically about any of our products. So with that, I think we can move on to the next slide. So I'll just this is just about our system architecture, and I might maybe just keep this in mind as we go through the life cycle of an energy management project in the future. But this is typically what the architecture of all of the systems that are intended to monitor energy look like. At the lowest level in this, you've got third-party meters, and they could be mechanical meters or ultrasonic meters or utility fiscal meter. So think of that as the existing or specialized equipment that is already in your client or your own manufacturing environments or industrial commercial sites of any kind. The next layer up can be, we'll just stick with that diagram just for 1 second. The next layer up is our wireless nodes, and they are providing communications infrastructure or communication capability to existing devices, or they are standalone, like the ZEM range there, that's able to monitor electricity usage without reliance on any other third-party product. It's self-contained. A layer up again is the infrastructure. So that's about getting data from point A to point B, the extremities of a factory or built environment of some kind back to central point. And then the gateway is the bridge in between the devices on site and the cloud where data is consumed. So that's kind of they're the layers in a typical energy monitoring system, and that pretty much applies across the board. Okay, so the stages of an energy management project. So we have mapped out. Again, this is based on our own experience, but the kind of stages or life cycle of a typical energy management project. I mentioned at the start that I'll go through these with a few insights that we've picked up along the way. Alberto is gonna jump in and with a few insights from his side and from his experience, and I will leave you with some nuggets of information along the way that are hopefully useful. So first of all, I'll just talk about the qualities of an energy management system that I think are important. So we have kind of developed a list of 7 qualities that are maybe worth taking down if you're in the market for a system like this. And again, it's not specific to us in any way. And those 7 qualities are accuracy, reliability, ruggedness, scalability, extensibility, interoperability, and security. Now, you might look at a list of 100 different suppliers and think, how do you evaluate them based on those 7 criteria? But I'll just speak for a minute about some things that are important when looking at an energy management system. So if you're talking about accuracy, the answer is sometimes hidden in the detail. So it's important to consider system level accuracy, particularly for electricity metering. And you want to be working with a class 1 or better system level accuracy electricity meter. That's an important point there. For reliability, again, how do you evaluate the reliability of a product? Well, you can look to case studies, obviously, and the trust that is built up in a particular supplier. But actually looking at the cost of the unit is a good indicator for that. Very low cost products include very low cost components, and that, typically speaking, at least, and that comes with a higher risk of high failure rates. Ruggedness. So to answer that question, you look at things like the operating temperature. A wide operating temperature generally means that the devices have gone through more comprehensive testing and are constrained in a way that increases their reliability. if there are moving parts, what is the kind of supported warranty period from the manufacturer, those kind of things. Scalability, how many meter points or how many feeds of data are supported by the system, how it can be extended, and look into the process and the complexity of adding new devices to the system. And a key one is interoperability. So can your system, the system you invest in, connect with multiple software platforms? Do you own the data? That kind of thing. And the final point here is security. So some questions to ask on the security side is, does the system support over-the-air updates? Have there been any third-party security audits done? That kind of thing. So 7 qualities in which you can use to evaluate the system that you select for gathering data from your industrial, commercial, or manufacturing environment. So on to this diagram then. It is important, in my experience, to set very clear objectives from the start and define what success looks like. And then you would, I guess, sanity check those objectives against what's typical, what's been achievable in other environments. Obviously, there's no one answer to these questions, but as a general rule, I've kind of broken the stages. It's broken this down into 5 stages. Procurement has nothing to do with analyzing data or any software platform or any hardware platform. That's simply going out to the market and looking for a better deal from energy suppliers. And that, if that hasn't been done, it makes sense to do this. And it could be not necessarily a cheaper one, but a more sustainable supplier, and that can have a significant difference. So that should be step 1 in any project like this. Pick up the phone and try and negotiate better contracts. All of the other stages require some kind of analysis of data, and it breaks down the 3 areas where an energy management system can really help, and where you're looking for your ROI are low-hanging fruit, behavior change, systems change, and then into CapEx projects. So low-hanging fruit, I would define as gross inefficiencies that are just staring out at you when you look at the data monitored over a particular period of time. And there's typically no cost in addressing those. It's just, well, we should not do this thing that's really expensive and it's a huge waste of energy or whatever. Behavior and systems change I would categorize as projects that don't require capital investment. And maybe there's some messages coming in there, but I can't see them. Yeah, I'll just assume that's not for me for the moment. Yeah, and then CapEx projects are projects that require investment to be made of some kind, replacing equipment, new control systems, that kind of thing. So on the metering side, so let's go on to the metering point now. So some considerations when you're selecting metering equipment. We have a site survey document for this that we can follow up with to everybody who signed up for the call, and that just has some information that you should keep track of when you're doing an electrical site survey. It's important at this point to have a marked up site plan and to start with a marked up site plan, and then to get some kind of an understanding of the distribution of electricity or the kind of utilities throughout the manufacturing environment. So where do they come in, where do they go, and what are the significant energy users within the environment? You should pay attention to currents, voltage levels, access to reference voltages, physical size, space, and also access to particular locations or if shutdowns are required. And all that information should be recorded for each area that you want to monitor and as kind of inputs to your metering plan. Now, let me just check on what's here. Yeah, so if just to inform the kind of level of metering that you would require, there's another rule of thumb here. You come at it in a few different ways, but going by energy spend is probably a good one. So if you, in my experience, monitoring down to the level of a $5,000 to $15,000 energy spend being monitored is kind of a good level of metering. So if you have $150K or euro or whatever of energy spend, that kind of energy spend might justify 10 to 20 meter points being installed in a particular manufacturing environment. Again, this is a rule of thumb, but it's not off by an order of magnitude. You would struggle to find for it to be economic to find use for 100 meter points in a, if you have $150K of spend in a particular environment. It's just ballpark rule of thumb. It's also important to I suppose accept that metering in complex environments is often a voyage of discovery. And that's why the extensibility of a system is quite important as well. So it doesn't make sense to pepper an environment with metering if you're not sure, or if you don't have the information to hand as to where those $15K spends are being made. So if you've got an extensible system that's easy to work with, easy to expand, you can put in a basic level of metering, knowing that you're going to need more, and then use the initial data that produces to dive further down into the detail. Final point on the metering side is about weighing up what's what looks like the cleanest technical solution versus the most economic solution. So it's important to consider delays and additional costs, maybe from interfacing to utility meters, maybe having to get specialists in to service existing metering equipment or something like that. Sometimes it's easier to just put in a new meter, even if there's an existing legacy one right beside it doing a separate job, just because of the additional costs or the additional hassle in interfacing to it. So that's something that should be considered at this stage in the project. Okay, I think we can jump on to infrastructure next. All right, so another rule of thumb here, in our experience, and this is informed by an evaluation done across a fairly large of industrial commercial sites, how much wireless infrastructure is needed to provide full coverage. And wired or wireless is another question that I'll come back to, but our focus is very much on wireless infrastructure. So one piece of infrastructure per 1,000 square meters or 10,000 square feet of industrial commercial site area is a good rule of thumb if you want to provide full coverage, full wireless coverage, giving you the flexibility to put metering wherever you want, to move it around, to expand the system over time, etc. Often, and this is dependent on the layout of the site and that kind of thing, but in many cases, that's not the right approach, and you have clusters of areas that need monitoring, and it makes sense only to provide wireless coverage in those areas, and then connect them together on your local area network or with Ethernet or something like that. So full wireless coverage versus clusters is a question, and then if it's full wireless coverage, what are the rules of thumb for the number of devices? What should be put into your budget in terms of number of devices per unit area? There's also wired versus wireless questions and good wireless versus bad wireless. And it's important not to consider all wireless systems the same. There have been many instances of bad wireless systems. Treating a wireless network as if it's a wire or wire replacement is generally not a good strategy for manufacturers or companies producing wireless metering systems. It's important to assume that the wireless network is going to break regularly, and by break I mean very temporary breaks in the communications, but it's going to be disrupted, maybe is a better word than break, and it needs to accommodate that. It needs to work around that. It needs to be able to switch into a logging mode intelligently, and when the network is available again, to upload its data and produce a full and complete data set. So not all wireless systems are the same. Ask your suppliers about the fail-safe mechanisms built in, and about the reliability of the wireless comms in terms of data retention, logging capability, timeization, that kind of thing. Yeah, I think they're all my key points on the infrastructure side. So on the IT side next. So there are two approaches that you can take usually. So one approach, and this varies by industry, and some industries have a preference for one and others for a different approach, but inside the corporate network completely or outside the corporate network completely are generally the two options. If you're sending data to the cloud, one option is that you keep the metering system completely separate to the corporate network. That can be the simpler approach if you just want to get in and out as quick as possible, and you want minimum contact with and minimum hassle from the IT department, or it could be external contractors or whatever. So outside the network involves using a cellular modem, putting in a data SIM card, and then you've got direct access to the internet, and the system doesn't touch any kind of sensitive corporate networks, and doesn't have to adhere strictly to corporate cybersecurity policies. The other option is keeping it inside, opening up the conversation with IT, and you should check that your supplier of choice has good answers to all of these questions about authentication and encryption, firewalls, roles, and user-based access, and everything like that. And ideally that they've been audited by some third parties. And as I mentioned, over-the-air updates are key, not just for the central computer in the system, but for every device in the system. That is a great way to evaluate whether a company is taking security seriously or not, is whether they can issue software updates to every device in the system remotely. Okay. Yeah, onto data transfer. So interoperability, I mentioned that before, and that is absolutely key. Things change. You might change your mind. The needs of the organization might change. Whatever. It is important. The data set that gets produced by these systems, particularly as we saw at the start in the poll, if you want to make the organization more, the decision making in the organization more data driven, having ownership of the data is very important. So you need to be able to take your data out and put into your own, backups or database or whatever, and you should always retain that option. And interoperability, you should be able to change suppliers at both levels. You should be able to, bring in additional suppliers in some cases. You might have a system that is monitoring some things, that there is this, niche proprietary software platform that you want to be able to send data to along with your main energy management platform. That should be supported and possible. It kind of relates to the point I said before about reliability. It is very important that you have logging and data retention capability at every level within the network. So if comms break down, if the power drops, whatever, that you don't lose data. So interoperability, extensibility, and data, let's say, are important at this level. Okay, so in my experience, again, leveraging on-site teams to do electrical installation is the way to go. It is there's huge value in using people that know the site, so that they could be the facilities people, electrical people, or contractors that work closely with the monitoring environment. Projects run smoothly when you've got people that know the site. It's not always possible, but it usually works best. You should consider the disruption to operations. Again, this depends on industry by industry. Some are less sensitive to it than others, but it is a reason to consider wireless communications over others, and also the how invasive the installation is particularly for electricity metering. So you can have electricity meters that are clip around the conductors, and you're away, or you can have a range of electricity meters that require, cutting and screwing, and an operation that would require an electrical shutdown to be done safely. All depends on local electrical standards, and they have to be adhered to, but that is an important consideration. Rules of thumb here for installation. Again, it can vary. Budgeting 1 hour of electrical installation time per sensor, range extender, or gateway. So any piece of the infrastructure, allocate 1 hour to it, and then use that as a back of the envelope calculation for the budget cost of the project. So it is important once the system is installed that you don't assume everything is working perfectly. You should go through a health check on the system, and that should have a number of aspects to it. It should be that there is a complete data set available from everything that's producing data over 2 days or a week or whatever, a month, whatever period you decide, but making sure that the data exists for every point in time that it should have been produced is important. But also that the data you're collecting matches what's expected in a particular location. And this is, again, why it's important to interface to the on-site facilities or operations teams or whatever, because it can happen that, in the middle of an installation in a dark, switch room or something like that, the wrong thing gets clipped onto the wrong conductor, and you're monitoring something that you don't expect, or that there's a problem in naming something after the installation is done. So having some idea of the load profile, or when a certain machine or area should be in operation, and the expected electrical load or consumption of gas or whatever it might be, is important. And finally, building an operating and maintenance manual as you go with any, and that should contain information on the electrical site survey that was done, the rationale for selecting particular products, serial numbers of products and where they were installed, photos of each location, and any passwords that have been set up, any configuration for data transfer. If people move on from the company or whatever, or the system needs to be expanded in the future, it's important to build up that information and have it, kept in good condition and up to date. And that's the last consideration on the commissioning side. So you have your monitoring system in place, you've got your objectives clear, you've got a metering strategy worked out, and you're starting to collect high quality data. It's time for a management process at this point, and that usually involves, and I won't go into this in too much detail because our focus again is the IoT infrastructure to enable this. But you essentially have to go around the loop of analyzing data, creating KPIs, maybe energy consumed per widget, use that data or ask questions of that data, use it to highlight inefficiencies, and create an action plan that changes behavior, changes configuration, or whatever actions you think are needed in order to reduce the energy spend. And that will yield results, and it's well proven. You can wrap it in a process like ISO 50001 if that suits the organization or not. But that's how you get from square one to a reduction in energy usage or improvement in sustainability for your organization, in my experience. Okay, that's maybe I think over to Alberto for some thoughts. Thanks for listening to all that.
Thank you, Brendan. So I wanted to, first, my name is Alberto. I'm a project engineer in EnergyCAP's project management office. I've been with the company for over 5 years, and my focus has been the smart analytics product. So this is my little world here. I work with many suppliers, one of them being EpiSensor. So I wanted to share, and Brendan has done a great job in going into some of these things deeper. Some design phase considerations and some things that might lead your project to success, right? So one of them is internet access. Having this simplifies. This can simplify the whole process of deploying these IoT infrastructure, right? Having a cellular modem on board, not having to deal with IT departments concerns and rules and etc. It will make your life easier, right? There are some signal and space considerations to take into account. That's aesthetics, if where you're installing this equipment, if the things are going to be installed indoors or outdoors, the kind of equipment that you can install outdoors, needs to be rated for that. Distances involved, right? In an industrial environment, these distances can be quite big. In maybe in the commercial world, you will have a lot of walls in between. So some considerations, and Brendan highlighted, looking at the floor plan when you are deploying a wireless system is really important. Third point I wanted to make is, and it's something very current, is that you look at those objectives initially, and you need to make sure which are the things that you're interested in. It's nowadays you have systems that export energy to the grid, right? And not every meter can do that. So you need to identify what is it that you want to monitor, and make sure that the equipment that you're purchasing can do that. So I put there imported, exported, and net energy, so kilowatt hours from electricity. So let's say you're exporting electricity to the grid, you have a PPA. Not every meter can do that. So if you identify those objectives and you match them with the right equipment, you will have a successful project. Again, people tend to think this is just an electrician's job, and there are multiple skills involved. You might need a plumber to work with a water meter, or you might need a technician to work with the heat meter, right? If you have like district heating, or you might need a gas engineer. You might need an automation person if you're dealing with Modbus or MBus, for example. You might need to get somebody from IT involved. So those skills need to be identified initially, so that when the time comes to deal with the Modbus meter, you have somebody who's capable of doing that, because your average electrician will not be able to do that. So identify those things, so when the time comes, you have the right people involved, and you're not wasting anybody's time and making the project more expensive. Local codes, I think this became more current after the pandemic, but a lot of facilities have health concerns. Let's say you're working in hospitals or care homes, things like that. You need to factor in all these health-related concerns, right? Similar thing if you're working in, let's say, schools, you're working with young children. You might need to do this project at a specific time of the day, or day of the week, or time of the year. Maybe you can only do it when the school is off, during the summer or something like that. So you need to factor those in to avoid delays, to avoid additional costs, frustration, etc. I think I cannot say much more than Brendan did about wireless versus wired systems, other than emphasizing that sometimes a wired solution is just not possible. I think a lot of the skepticism around wireless systems comes from the past, from cheap solutions that don't work. There are methods, there are tools that can help you design and deploy a wireless system successfully, and those need to be incorporated into your procedures for designing and doing all these, right? Last item there is using battery-powered solutions, another controversial topic, because batteries die over time, but sometimes these can actually simplify the process, and there are ways to configure the system that it will save battery and last longer, etc. And you will have high quality data, and the system will not be crazy expensive to implement, etc., etc. So just some of the things to consider. You can. Thank you, Amber. So we've talked about a few of the stakeholders in these energy monitoring projects, and normally the people that you have on the left are the people that are usually on board, right? This is the owner, the operator, this is the company or person purchasing the system. Then you have the people who are going to use these data. That could be your energy manager or your data consumers, right? You have the hardware suppliers. That could be EpiSensor, for example. You have your installer. That's your electrician, your plumber, your gas engineer, etc. And then you have the software provider, which could be EnergyCAP, right? These people are usually on board and trying to get the project across the line. But then you have people on the other side which might not be on board. IT departments might have cybersecurity concerns, privacy concerns that you need to address. And one way around this is to use a system that will not rely on the corporate network, as Brendan said. You might have, and Brendan also brought this up, you might have to get utility companies involved to open a cabinet for you, to enable an output on a meter. And they work on a different time scale. They are not desperate to get the project across the line. So you need to factor in their timelines into your project schedule to make sure that they align. They can take forever. They can kill a project just like IT departments can. And then if you're working in, for example, commercial real estate, tenants can be problematic. Sometimes when you're working in, let's say, a multi-tenant building, all these people need to reach an agreement before you can, let's say, cut the power to the building to install your system, or before you can go in and do something there. So they can be complicated. So it's important that all of these people are taken into account from day one, not when the moment comes and then suddenly the project comes to a standstill, right? So communication is really, really important. You're trying to get people engaged, committed to the project. And again, factor in facility-specific procedures and rules, local codes and regulation. The easiest way to go around this is to use, as Brendan also mentioned, a local installer, ideally a person who works with this facility on a daily basis. They know these procedures, they know the facility, they know how to get things done. You don't need to figure this out. Every country, every building has different rules, and it's hard to know them all. So if you have this insider perspective, it will make your life a lot easier. You will not have to go to site to do everything yourself or send somebody to site. Maybe you can check with this person what's going on site before having to send somebody over there. Next slide, Amber, please. Yeah, so last I wanted to provide let's say my perspective as a user installer of EpiSensor systems, right? And many of these we've discussed before. One is the versatility, right? You don't have separate systems to measure power, to log pulses from gas and water meters, to connect to MBUS and MBUS devices. This is one system that can do all of these things. Plus, it can also for example, measure environmental variables such as temperature and humidity. So one system to acquire this data, and then on the other side, you have one software that can ingest all this data. That is EnergyCAP Smart Analytics. So you don't have multiple products on one side and multiple dashboards to visualize and analyze this data. You have one system on your site, and then you have one piece of software where you can visualize and analyze and report, et cetera, right? A few features that stand out for me are the remote access. This means that once you leave the site, if you need to check something, if you need to reconfigure something, you can do it from your home, from your office. You don't need to go there, get permission, get access to the gateway, and go there and connect with your laptop. You can do it from your home, check something, reconfigure something. Again, the SIM card, the cellular modem, really can simplify things with IT. All EpiSensor equipment comes in IP67 enclosures. That means that it's rated to be outside. You don't need to do anything special to install it outside. It's already rated for that purpose, right? Some common electrical issues such as CTs, current transformers that were installed the wrong way, or maybe the CTs were installed on the wrong phase, right? These common electrical issues can be addressed via software. So that is also you will not have to send the electrician back to site to correct these things. You just log in, reconfigure the node, and that's it. You're getting the readings right. But this is part of the validation process that Brendan described, right? It's important that you go through this. Battery versus mains power nodes. Sometimes you cannot just run a power line out there where the gas meter is. So using something that is battery powered makes the thing feasible and makes the thing less expensive, right? It's a system that is expandable and highly configurable. You can start small and then grow as you prove the value, as you learn about it, as you determine which are the next needs, right? The connection between the EpiSensor gateway and EnergyCAP Smart Analytics is a secure connection via HTTPS. JSON packets are being posted every few minutes, depending how the system is configured. So secure connection, no security concerns there. Support is top notch, and this is really important because every building is a different story, and you are learning, the technology is evolving. So you need to you need to have good support, and this is something that we get from EpiSensor. For me particularly, I'm in Dublin, so working with a manufacturer that is local is great. Lead times are pretty much zero. We order something today, we have it tomorrow here. So that is that is not something I can say about some other manufacturers. Their products are designed and manufactured here in Ireland. I think Brendan already touched base on some of the challenges of working with wireless systems and how to deal with them. And he also gave a small introduction to what they are doing in demand response, renewable storage, so all the new stuff, the exciting stuff. So I think Brendan has a short case study to share with you.
We can't hear you, Brendan. I think you might be on mute.
Yes, thanks very much, Alberto. That's great, and we might run through this quite quickly because I'm conscious we want to leave some time at the end for questions, that just to get the best value out of the time. So this is just a case study in a manufacturing environment. It's kind of a reverse manufacturing environment where instead of components coming in and a finished product coming out, the finished product comes in and the components go out. So this is a large food processing or meat processing plant where 300,000 cattle a year go into this factory. They had a 6 million euros energy spend at the time of doing this project. They installed 300 monitoring devices that expanded to 450 over a period of a year or two. Giving them visibility of down to about 10,000 euros per device of energy spend. And the results, or some of the outcomes, were a significant improvement in data-driven decision-making, savings and ROI that was very short. Water leaks, and also water leaks identified, and also compliance problems identified where water that was intended for disinfection that wasn't at the right temperature. So they're actually doing environmental monitoring and energy monitoring within the same system. And the rationale or the motivation for implementing this system was sustainability requirements being pushed back through the supply chain from their end customers. And that might resonate with some of the people on the call as well. So I might leave it there and with this case study, and if that makes sense, Amber, to switch over to questions, just conscious that I leave enough time for that.
Sure, no problem. So yeah, feel free to jot your questions down in the questions section of the toolbar. We have a couple here that are sustainability specific. So one question is from a manufacturer saying, they are getting some requests from customers to report on carbon, and they're asking us kind of how would we go about getting started with that. I don't know, Brendan or Alberto, if you want to take that.
That's maybe one for Alberto, and it's probably more a feature of the analytics software platform than something on our side.
Yeah, so with once the data is in smart analytics, you can all the EnergyCAP products are interconnected. So the real-time one is smart analytics, but there are a couple others that Amber showed at the beginning, the utility management, and then there is also Carbon Hub. So let's say behind the scenes, all these products are connected. So if you have your energy data coming in through smart analytics or coming in through utility management, then you can use this energy data together with rates and to report your carbon emissions in Carbon Hub. I think Amber, you can go deeper into that, but yes, it's possible to use this energy data to build your carbon profile there.
That's exactly right. You know, our solution is holistic, and you can, you know, if your needs are more around diving deep into your operations and you know, understanding and detecting outliers in real time, that smart analytics is a solution for you. But that's not to say you can't pair it with our other products and solutions to support your needs. So we have utility bill management if you need to do scope 2, carbon accounting. That's a great place to start and pull that utility information in. And then we have, of course, our carbon accounting solution, Carbon Hub, to do all of that ESG reporting, have that, you know, data be financial grade for your carbon accounting and reporting to your customers. It's something we're seeing a lot, especially in manufacturing, the pressure to report to customers, since you guys are on the supply chain. So it makes perfect sense. Good question. We have another question here about how we handle measurement and verification options, B and C. Alberto, do you want to take that one?
Yeah, so IP MVP. So yeah, once the data is in smart analytics, and this is not only smart analytics, but let's focus on smart analytics. You can use that data to build your IP MVP project, right? And determine what are the avoided energy usage, etc., from whatever measures you've taken, right, to reduce energy usage and emissions, right? So yeah, there is in smart analytics there is a tool it's called the MNV tool, measurements and verification. So the MNV tool allows you to go through this IP MVP process and build your baseline, and then your reporting period, and incorporate all those measures that you took to improve your energy efficiency, and validate those following, you know, the process that is part of IP MVP, yeah, the protocol.
Thanks, Alberto. Brandon, I think this question's for you. It says site surveys. Does EpiSensor do site surveys?
In some cases, yes, but our default is to kind of enable our end customers or partners to do that. We have a site survey kit, and we have a lot of documentation. And in some cases, if it's local, or if it's a particularly large project, we would. But we can also advise contractors on how to do it, or provide some training. So that would be our first preference: documentation, training, support calls.
Excellent. Well, that is all the questions we have received. So if there's no further questions, I want to thank you both, Brendan and Alberto, for joining us today. And thank you all for tuning in and sitting through this presentation. As I mentioned, we will be sending out the recording soon after. So expect that from us sometime tomorrow. Thank you, and we hope to see you on our next webinar.
Thanks very much.
Thank you. Bye-bye.